let's look at this the idea about derivative and antiderivative, and then we look at a couple of examples. Get a pen on. First of all, right, if you have a function, you derive it, you get dy dx, and of course the idea is that it's like a two-way street. You can go from dy dx and back to y. So if this is a derivative, and going back from here to here is a process of antiderivative, and to dy dx, y is the antiderivative. Okay, now so let's look at this one. Let's try B, and they ask you to find antiderivative of this expression by differentiating this expression. Alright, cool. Let's do this. So it means we're going to do this. I derive this. Differentiate this expression. You would get this. And however, you're being asked to find the antiderivative of 6x squared. Here, however, we only have 3x squared. To get 6, we times 2 across, right, the whole equation, and we end up with this. So you see on your right hand side, now you get exactly what is required in the original problem, and you do realize that the constant coefficient is not affected when you derive. So we can kind of like multiply this 2 into this expression, and there you have this. See, you see. So that means if you derive this or differentiate this expression, you get 6x squared plus 4x. On the other hand, the antiderivative for 6x squared plus 4x, that is going back here, is therefore this 2x cubed plus 2x squared. Okay, right, you get it. Now let's move on to another questions. Same exercise. 6C2. Let me get a pen on. The second question. So let me choose one. How about this one? Right. And when we differentiate expression, especially constant. Now look at this. So y, say x squared plus 4. If you differentiate this, and the idea I'm talking about this because of this sentence in brackets. Why they ask you not to forget the integrating constant. See, look at this. If you differentiate this, especially get 2x. Okay, fine. Everybody knows that. I mean, if you're familiar with calculus. However, there's actually a slight problem if you get this problem and it asks you to differentiate again, and you get 2x. Again, it was similar. Well, in fact, they're the same. And then the problem arises. That is, if I differentiate this function, I get 2x. A different function, I get 2x. Now, wouldn't it be a problem when I try to find antiderivative of 2x, because we do not know whether the antiderivative is this one or this one. So therefore, when we try to find antiderivative of any function, we add a constant c, because there could be a 4 there, it could be a 10, it could be anything, it could be a negative 10. So to safeguard against missing that constant, we put a plus c at the end every time we integrate actually. So look at this. The question now is given this. derivative, which is x to the power negative 2. Right, you ask yourself, what function, when you derived it or differentiate, you get x to the power negative 2? Actually, this answer is simple. There's only one, that is this one. You derive this expression, this function x, this term x to the power negative 1, you get x to the power negative 2, because when you differentiate, you subtract 1 at the exponent. So we then know that the antiderivative would look something like this, right? And so what we do is we try and do this. Let's derive this. So this is a thinking part, okay? So we try to derive this or differentiate this. This is always a more common way to say it. Now, doing this, you get negative 1, right? Copy the negative 1 in front. X minus 1, you get negative x the power of negative 2. And so that means we want to make this balance. We want to get x to the power negative 2. So multiply by negative 1 across. And what happens is that now we can multiply negative 1 into this expression. We get negative x to the power negative 1. And then your right hand side now becomes this, no more negative. And this is exactly the function, or the expression I should say, that given to you. So that means what? It means that the antiderivative, so what we're going to do is we're trying to find the antiderivative of 1 over x squared is negative x to the power negative 1. And so therefore we want to find y. So y is this function. Now do not forget that at the beginning we'll talk about this situations. There might be a constant which we do not know of, and to avoid that making a mistake, forgetting some constant which we do not know of, we plus c. And you might be able to check that if you differentiate this, irrespective of the values of c, it could be 100, negative a million, whatever that is, you differentiate this, you always get this.